Welcome, class 221B. This is group 6. You're doing lesson 13 today. All right, you guys ready?
Yep.
All right. Distribution outlet up. Just take a sec to download everything.
What requirements must be checked when conducting a hypothesis test comparing two means with independent samples? Sample random samples, John. I think it's the first one, definitely, right?
Yeah, the first one.
It's multiple.
So, because the second one, so you think about the other ones with only one group, you know, you have to know that the mean is like normally distributed. So I guess it makes like.
Well, it's if you think about it, you can't. It's like you can't compare apples and oranges because they're two different things. If one is left skewed, one is normal. They're simply two different things. So exactly. Now the plus side is if one is normal and one is skewed, but the sample size is high enough, it is still normal.
Yep. Yep.
But yeah,
I think it's all but the last one.
I don't think it's. I think it's just the first two.
Oh, you're right. Yeah. You're totally right. Yeah, you're exactly right. Yep.
That would not equal to, greater than, less than, whichever.
Yep. All right. 4. The test statistic for hypothesis test comparing two means independent variable is
the t-score.
Yeah. Two samples are independent if A, knowing which subjects will be in group 1 determines that, or determine cancels it out. Knowing which subject will be in group 1 tells you nothing about it. I think that's obvious.
The first one would be
the paired.
The paired, yeah.
Sorry.
Perfect.
All right. So I'm going to give you all, basically we need to input the office dentist bill thing into our inference sheet. So let's just take a sec to do that.
The first one should be 20.
Let's see here. I should have just got this all pulled up before we started. Makes it so much easier.
Yeah, I was working on the homework for last lesson before class.
So guys, last time we met, I pulled up the homework quiz for 13 for like this one. And so I've had that one open for like days, and so I can't get notifications, and so like it sucks.
Yeah.
I did it again.
No, you did. With 14?
Right. No, not today. But like I did it because I did it again like a couple weeks ago, and then I did it today too.
I was like, man.
Yes.
Okay, so is 19 that first one?
All right, give me 1 sec to pull this back up. Degrees of freedom, yeah, 19. And it's kind of weird. They give you the end. They also give you degrees of. Is it really 19?
Am I looking at the right one?
So let's see.
I was looking at the dentist one. Sorry.
Which one are we doing first? Dentist, right?
No, we're doing the freshman.
Wait, the dentist office bills. Yeah, is the first one.
Is that what we're doing?
Yeah.
The degrees of freedom, I got 27.996.
Let me make sure I pulled everything over. I'm getting
37.996. Because you have to put it under the 2 sample t-test, so it's not the paired sample one. It's the 2.
Yeah, I'm also getting 37.996.
Yeah.
Can you copy 2 columns and paste them at the same time? Will that cause any problems?
You can do that, but you have to make sure where you're dragging it to is the same. So if, say, you're dragging 2 columns and it's the pair sample test, you had 3 including differences, you just got to highlight the 2 columns you want to draw it to. Otherwise, it will mess up. That makes sense.
And so you want to do the 2 sample t-test.
Yeah, I know. I'm just giving an example.
Yeah.
But that in the 2 sample, it's pretty easy because just go ahead.
So you're getting the DF is 37 or
0.99.
Yeah.
That makes a big huge difference.
Sample.
It makes sense because it's going to be like all of them, if that makes sense. Like, I think, right? It's going to be all from variable 1 and all from variable 2.
Well, essentially, the 2 degrees of freedom combined. So you get 19 and 19, which is essentially 38. This is slightly off because
who knows why?
Yeah,
But, yeah. I remember it saying in the textbook just to go with what it says in the program, even though it's not a whole number.
Yeah.
Hey, I like technology, man. I'm good with that. So.
All right. So Rexburg is the variable 2. So in the standard deviation, we're looking at the standard deviation of variable 2. So it's 206.637.
206.637.
Love copy and paste.
I like these ones where we don't do anything by hand. It's all computer.
I know, right? Too bad all math can't be like that.
Yeah.
Wait, you got 206.637?
Yeah, for the standard deviation of variable 2. You might have put them in backwards. Did you get that for the first one?
I got that for 7.
What?
Oh, yeah, for 7, 206.637. Yeah.
Okay, yeah.
Sorry. And then number 8
was I'm seeing Brooks. I think I'm seeing you got that one different.
What, 7? No. Oh, yeah, I inputted it wrong. Sorry.
Oh, yeah. Okay, yeah.
Yeah,
cool.
no, I meant to. The 6 got dropped when I was typing.
And then the T is negative, huh?
Yeah, it's negative 0.434.
Cool.
Negative 0.434, yeah.
Is it important to have that 0 in front?
No.
I would say yes, maybe. I don't know how he puts it in, because sometimes like teachers will put multiple answers in, so like it'll be right if you put the 0 in.
Yeah.
But I don't know how he does that.
Yeah, it's better than risk it. The p-value 0.667.
0.667.
So I'm assuming we're not rejecting it.
Yeah, because it's a pretty big number. Does it
All
have
right.
the degrees?
Level significance is 0.1. I mean, pretty much if it's over, anytime your p-value is over like 10, 0.1 is pretty much guaranteed to be true.
Exactly.
That makes sense. I mean,
So
I
we failed
should say
it.
true because it should be fail or reject, but. All right.
So suppose instead you would use the alternative
Oh,
hypothesis.
hey, I noticed we did which nor. Did you make sure you put in,
Oh, shoot.
you see what I
We did it
mean?
Freak, we did it wrong.
Yeah. All right, most of the stuff is the same. The p-value is different, though.
So we want to do greater than, right?
Less than or isn't it variable 1 equals variable 2, so would it be less than?
Well, you want to figure out if variable 2 is greater than variable 1. Right?
Yeah, I think it's.
How you? Oh, that's true. Or are you trying to figure out if
Sounds perfect.
variable 1 is less than variable 2?
I'm gonna go with less than. If it's wrong, we just switch it.
Okay.
All right, so the only thing we need to change is our p-value.
Oh, wait.
Yeah.
So,
It is less than.
yeah, that's right. So the only thing we need to change the p-value is to 0.333.
Yep. All right, now we can change it to not equal to. All right, it's gonna be B, right?
Suppose, what is the correct? So we have sufficient evidence that the mean dentist are different. We have insufficient evidence that the mean dentist bills between the two cities are different.
Because our hypothesis or no is that they're the same.
Mm-hmm.
So I would assume since we're rejecting this hypothesis.
Yep.
All right, now we do the freshman did our statistics. So give you guys all a sec to change those out.
I already downloaded that. Why did Oh, I have so many open here.
I think it's because when we're doing like a video call like this, it just takes forever. That's how it is for me anyway.
Yeah.
All right, now the sample sizes are slightly different for these two things. So make sure you did it again.
And let's see, what's the alternative here?
All right, so the null hypothesis are equal. So
It's not equal to.
Yeah. So it is looking for a different number, so it's not equal to. That's correct.
The appropriate alternative hypothesis. Why is it that? I don't know.
Well, because you suspect that the freshman from Utah took different cells, a different number. Doesn't say whether it's higher or lower. This is different number.
Gotcha. Okay. Yeah.
In which case it's not equal to.
That's easy.
Test statistic is 0.845.
What is p-value? So I'm in 0.411.
You have 0.411.
What decision do you make? What's the
level significance is
Failed to
5.05, so it's definitely failed to reject.
So far, every single practice one I've done, we've failed to reject it.
I think.
failure?
Well, and I think part of that has to do with the fact that the null is pretty much accepted. So in order to fail to reject it, you have to have an extreme value, and extreme values are pretty rare.
Yeah, makes sense.
Especially because you don't simply just look at one survey. You're looking at the sample population in the whole. It's harder to get an extreme because again, it's extreme. All right. U-1.
So determine a 95% confidence interval. So 95% confidence interval. Okay. For 1 minus 2. Determine the margin of error for this 95% confidence interval. So it would be
3.681.
So how'd you do that? Did you do negative 2.214 minus 5.147 divided by 2?
I did 5.147 minus negative 2.214 divided by 2. Yeah.
See, it just throws me off because like it's saying determine the confidence interval for 1 minus 2. So wouldn't you want to do it the other way?
It's the same thing, I believe.
Yeah, I can do it just for giggles.
Okay.
Well, it's different because when you're doing the negative, if you do the upper minus the lower, it goes up because it's a negative. If you're doing the lower minus upper, I think it would go down.
It's the same.
Okay, never mind.
And what was the answer?
It's negative 3.681. That's rounding.
Are you sure that's the same? Because when they did 5.147 minus negative 2.214, I got 7.361.
Divided by 2.
Divided by 2, that's right. So I got 3.681. Is that what you guys get?
Yep.
Is it negative or positive?
It's, good call. It's negative.
Are you sure?
Yeah, that's what I'm getting. Let me try it the other way around, though.
Well, because it's different depending which way you do it. This one specifically says U1 minus U2, so the question is which one is it?
I would say U1 minus U2. So I would say
do we need to compute it by hand?
Yeah. So it would be negative then, because if you do the 1 minus the 2 instead of the 2 minus the 1, then it is negative.
All right, I'm cool with that.
Yeah.
It's
So
because
I'm trying to think of like what Brother Esplin said. So like you subtract the upper or the lower from the upper, right?
Yeah,
And
give me
then-
1 sec. I'll pull it up.
Yeah. Let's see what he says.
I mean, it was. So where is it?
I forget which way, because like definitely gonna make a difference. Because one of them you could find the margin of error, and then the other one you found
All
something.
right, here it is. So simple method of finding margin of error when you already have computer confidence. Subtract the lower limit from the upper of the interval. Okay, and divide the result by 2.
Yeah, and so the point estimate you can find by doing that plus or minus 3.5, or the lower and upper.
Yeah.
Okay.
Or the point estimate will be number in the center of the interval.
So we're going to do, I need to go back to it. So we're going to do 5.147 minus negative 2.214
Yeah.
divided by 2.
Yeah, so it is going to be positive.
So positive 3 point.
So it is the second minus the first.
Yeah. Well, it's the upper minus lower, not second minus first. It's upper minus lower.
It's just throwing us off because it was saying 1 minus 2, but that's kind of irrelevant, I think.
Yeah, I think it's like one of those like things they throw on the thing to make you confused.
So
Dang statisticians.
so then the next one is negative 2.214.
Yeah. And upper is 5.147.
5.147.
Watch
Alright,
it. Watch
I'm
it. Wrong.
I know, dude. I'm gonna be.
See, after
We're being
what
too
happened a couple
confident.
weeks
We're
ago,
way
I'm
too
super
confident.
nervous turning these in now.
We're way too
Because
confident.
like last time, I was pretty confident with our answers last time,
Yeah.
and then we got a 70%.
Well, I zipped through one of the tests on my first round.
There's only one. The test statistic is wrong.
Okay.
Out and up and lower and upper bound are wrong.
How? How is that wrong?
All right, there's feedback right here.
Let me write this down. Which one was it? The last
13,
one?
test statistic.
Okay. 17 and 18.
And then, yeah, 17 and 18.
Okay. Let's fix that then. What the heck is going on here?
The answer in SPSS is slightly higher than in Excel. So the answer given is the average between the two results. Your result should be close to the answer shown.
That means you can go back and change it.
What's the SPSS?
That's like the Microsoft statistic program that we don't have access to because it's expensive.
So the answer given is the average between the two results.
Let's go back and try to test this again. I'll be inclined to just send him a message and see.
What does the feedback say for 18? Is it pretty much the same thing? Probably.
Yeah, it's also 0. Let me look at here.
You know, I called him the other day. He answered. He was really nice about it.
Really?
Yeah, he was super nice about it.
Yeah, he's a nice guy, and he responds quickly too. So.
Yeah, he's way on things.
All right, so let's. I'm gonna mark down my answers. You got them, Camden?
Yeah, I do.
All right, I'll do it anyway. Give me 1 sec. All right, so this is gonna take just a sec. I want to write them down.
Do we put? Hold on a second.
How could we mess like the test statistic up, but not the p-value? Like,
Yeah, I don't get that.
like if anything, it's gonna be the p-value. Like,
1, 8, our test statistic is correct.
Okay.
So let me double check something.
Yeah. So that's what I don't understand. Is like then how would our second one be wrong?
Because if you change it to like greater 2, it still doesn't change. Nothing changes as long as all those numbers are in there.
Yeah.
The only thing that changes is the p-value.
I'm getting close. Sorry.
If we did it right the first time, how did we not do it right the second time? Because we did it the exact same way.
Yeah.
Right.
Because he basically said in information just use the computer.
Yeah.
Right. So I'm just about there. All right. So 13 is what we need to work on real quick. What is the test statistic? When our confidence, our confidence intervals were also wrong on 17. So we got three things wrong.
Right?
We got 13, the test statistic for the dinners. We got 17 and 18, which is weird because our margin of error is correct.
How can that possibly be?
I suspect he may go in and change 17 and 18 because it's probably just a computation error on the computer's part. You know what I'm saying?
Because if we got the margin of error right, that would have to mean we got.
I suspect because it was done in SPSS there and due to the feedback, I suspect that we change. I'm cool to keep this score as an 89, but let's fire. What about you guys?
Yeah, let's just send him an email. Or Brooks, do you want to send him an email and see what he says?
All right. Well, let's finish up our video here. I'm going to, on my collaboration like I did last time, just make a note of these three things.
Okay. So we got the margin of error right, and so
yeah, I'll basically say, hey, we didn't get our test statistic right, even though we took it from the computer. We also did miss the confidence intervals, but our margin of error was correct. Can you please explain how what we can do to fix this next time?
So, I think it would be good too to say we suspect that there might be a computation error, a computation error
in the quiz.
All right, I'll mention that.